Alright, in this tutorial I'm going to show you how to install Algodoo and use it to carry out investigations about the weighted hoop experiment. Okay, Algodoo is a free piece of software that you can get if you just search for Algodoo and download, and then click on the first link, and you get all these options. So whether you're a Mac user or a Windows user, just click on the appropriate button, and it'll download. It'll give you a setup file. Run the setup file. When it's finished, it'll give you the option to launch the application, and when you launch the application, you'll get something like this. And I'll just create a new one so I can show you from scratch. And this is like a physics world. This is a simulated two-dimensional version of the real world, where Newtonian physics works. So, for example, if I make a little ball here, I hit play, the ball will accelerate downwards at a rate of 9.8 meters per second. That's not what I want to do. What I want to do is create a weighted hoop that I can apply a force to. So I'll walk you through the process of doing that, and then you can have a play around with it and bring in any questions that you have on Tuesday. So the first thing we're going to do is create a circle, and we'll make it a radius of 1 meter. And then we'll create a second circle of a radius slightly smaller, 95 centimeters, like that. Oops, we don't want that one. Then we can click on this move tool to move stuff around. But before we do, we'll just turn on this grid. Okay, and we'll take this 1 meter one and snap it into a 1 meter by 1 meter square. And the nice thing about the grid is that everything kind of snaps into place, so it's easy to locate things. I'm going to take this 95 centimeter one. In fact, I'm just going to make it black to so I can see it more clearly on top of the other one. And I'm going to move that so it's exactly in the middle of the other circle, exactly in the middle. And it snaps into place, so we know it's exactly in the middle. And then I'll right click on that, and I'll go down to Combine Shapes and Cut. So now I use that black circle to cut the inside of the white circle out. I'll erase these two because I don't need them. And then I'll take this one and I'll just set it down on the ground here in the middle. So now we have a hoop, and I'll just show you how this program works. If you hit play, you don't really have a reference point, but if you hit play and you take this little drag tool, you can give it a push and it'll kind of roll. Okay, we'll stop that. That's not quite what we want to do. What we really want to do is add a little weight here. So to do that, I'll just zoom in on this hoop that we've made, and then I'll just move the screen a little bit, and then create a little box, and I'll make it that size. And then I can take the box, oops, not like that. I'll use the move tool to take the box, and I kind of want it in between those two positions. So in fact, I'll just make the box a bit smaller. I'll get rid of this one and I'll make a new one that is exactly, in fact I'll make it 3. That'll just create a nice symmetry. And then I'll use the move tool to move it up to there. Now I don't really want it sticking out like this. It's going to cause the whole rolling motion to get stuffed up. If we take away the grid, then we can move this without the restriction of it having to snap on. Put the grid back on just to check that it's still in line with those two lines. Yep. Okay, so now we have a little rectangular weight attached to the inside of this hoop. It's not quite attached yet. We need to attach it. So to attach two objects together, we just use this little fixate button, like that. so now that's attached, hopefully. But it looks like it's not quite on the right place, so I'll just put it a bit higher up. Yep, oh well, that's as good as it gets. And then I'll just zoom back out. So now I have a hoop with a little weight at the top, and let's just have a look and see. In fact, I'll zoom out a bit more so we can see a bit more. If I give this a little push now, oops, I'll hit play first, it'll roll. And then stick, and then roll back, and it'll oscillate, which is kind of cool, which is just the experiment that you want to do. Now we want a controlled way of applying the force rather than giving it a random little push with that finger. Okay, let me just zoom out like that. And so to do that, what we need to do is take this thruster. Okay, and then actually we need to zoom back in again, right in. And depending on where we want to apply the force, we might want to apply it up the top here. We might want to apply it exactly in the middle, in line with the center of mass of the hoop. So let's do that first. We can take the thruster, and to apply this thruster we need to get rid of the grid, otherwise it tries to put it either there or there, and it doesn't seem to like that. Get rid of the grid, and then apply the thruster. You can make it a 1 Newton force, and we want it at exactly at 0 degrees. Yeah. This is tricky. I think we can change it afterwards. I'll just put it on. We can change the numbers here. So we want to change this to 1.0. And can we change the angle here too? No. Okay. Let's just change the angle a bit then. Odd. Okay, well it's close enough to horizontal. And 1 Newton, and we want the thruster to always be horizontal as it goes. Okay, so now we have a thruster attached to it. We'll zoom back out. Maybe we'll put the grid back on just for a reference, and then we can take the we can take this moving thing, because as it's going to move from left to right, we kind of want it to be there. And then we can save this. We can call this hoop with weight and thruster. Okay, and then another thing that we want to do actually before we start is just create a key that allows us to turn the thruster on and off. So if we click there, and then maybe a key that won't be assigned, maybe comma, and then we'll use that to toggle the thruster on and off. Okay, and then zoom back out and move the whole thing over this way. Oh, actually, one other thing. Move it back to the middle, zoom in. We kind of want to add a tracer to this thing, so we can see how it's traveling. We can do that with this button here, the tracer tool, and we put the tracer right there, and then right click on it. Oops, we might need to zoom in so we can see what we're doing. In fact, I'll just get rid of that tracer that I put there. And then I will zoom right in so I can position the tracer a bit better. click this tracer button, and I'll put it a little bit above that one. Oh, I didn't like that. It's because the grid is on. Now I can put the tracer where I want, and I'll put it just above it there, and then I'll right click on the tracer and I'll let the tracer stick around for about a minute, and this will now trace the motion of that point. I'll show you what I mean. So I'm going to zoom out, and then I'm going to move the whole window this way, and then I'll hit play. And you can see that the weighted hoop is moving, as you'd expect. And eventually, because there is a bit of friction still, I can turn that off, but there is in this. Eventually it'll run out of energy because of the friction, and it won't have enough kinetic energy left to get the weight up to the top, and it'll roll back and it'll start to oscillate. And the amount of gravitational potential energy in this system is shown exactly by the shape of this tracer, which is kind of cool. Okay, another neat thing that we can do with this is, let's just go back to the start, is we can add a graph. If we right click to, oops, it's very hard to pinpoint where I'm right clicking. So if we right click on the hoop and we click show plot, and we want a speed time graph of this, I might just zoom out even more so we can see a bit more. We can watch it rolling as the graph is plotted, and then we hit play. There's a graph of the speed of the center of the hoop as it rolls. It went down to 0 there because that's where it changed direction and started rolling backwards. And once you've created that graph, you can pause it and you can save that as a CSV file. And when you show that file, what you get is all of the time and speed data. Which is kind of cool. So that will allow you to work out the kinetic energy of the hoop minus the mass. You can group the two together and get the total. Okay, so that's the basics of this Algodoo program. I think it'll be quite powerful for modeling the hoop and for carrying out some simple investigations into things like changing the friction, changing the mass of the hoop, the thickness of the hoop, the size of the little mass that's added, the size of the force that's being applied. You just need to be careful to confirm a few of those experiments with real ones.